Hi guys, this is Sandro from Soundnews. I just arrived at Ferrum Audio Factory, so I'm going to show you how everything is being made, the manufacture process, everything really, the offices. This is going to be really excited, and you're going to see how the DACs, headphone amplifiers, power supplies and cases are being made, so this is really cool. Let's go!
Okay, hi, I'm Max. I'm the head hardware designer in Ferrum, and I will talk you through our factory. Well, let's begin. Here we have our testing place when we test our devices, and also they are burning for at least 1 day. So they here stand on this desk, and after there is enough time and they are checked and everything is all right with them, then we can pack them.
So they have at least 24 hours of burning?
Yes, at least 24 hours of burning.
Great.
And here
what do we have right here?
Here we have our prepared cables or splitters. So here are power splitter for our Hypsos system to split the power for two devices, and different cables with different connectors. So here are, for example, 5.5 2.1 millimeter barrels, and here are 2.5 millimeter barrels. Also, somewhere over here should be micro USB cables and even our double VAPU connectors for connection, especially for our devices, because in our devices we are using this VAPU connector on both sides, so we are able to measure the voltage on this device, not on the connector itself, which is with this connector, but on the motherboard, because we have 4 pins in those connectors.
Okay, can you say something about this?
Yeah, here wyroby niezgodne means that faulty device.
Okay.
So here we have devices which didn't pass the test, or there were some problems with them, and they're going to be fixed. And after they are fixed and they go again from the whole procedure of testing, and they get enough burn, then we finally are able to sell them. But right now they're waiting for better times.
Okay, makes a lot of
because
sense.
They cannot leave the factory in this state.
I totally understand.
So urządzenia do pierwszego testu means devices for first test, because we have multiple phases of tests and we are doing them multiple times. So here are devices which were when they have some software, they only have the software in them. They were flashed, but they need to be tested for the first time. And after the first time, after the first test, they go onto this stand, and here is a second test.
Okay.
So after this, when
double checking basically.
Yes, double checking basically, and after that, when the device is after the second test, it goes here, and here there are devices which are after second test and they are ready to shipment. So from now on, they are ready to be packed in the box, and then we can ship them to our customers.
Lots of devices ready to be shipped. This as well, right?
Yes, this as well. And for example, here is his Golden Sound Edition version of the Wandla. So we just, to make sure that we're not gonna get mixed up, because it's only a software change. In terms of hardware, it is basically the same. Mm-hmm. That's why we need to, after the flashing procedure, we need to have some sort of without, of course, turning on the device, because then you can tell which one is which. But without it, we need to prepare ourselves. And here are the boxes which are actually ready to be sent to our customers. And when they are brought together, then they are packed here. On this table, they are packed and they go into those boxes. And then the delivery comes through that door.
Okay.
And they take the boxes to our customers.
Are you doing anything here?
Yeah, I mean, sometimes if we have we need to change something in our prototypes, or we have some defects with our PCB boards or the cases, we are making some adjustments here, so we can, for example, cut some holes in our PCBs and all this sort of stuff. And well, this is the place where it all happened.
Really
basically, many of them, we can make many of the mechanical procedures here. So here we have our storage also.
Different power cords.
Yes, different power cords. Standard power supplies for example, this is for Wandla. Zasilacz means power supply, and here are our small boxes with the standard default power supply which you have when you're not using the Hypsos.
Yeah.
So yeah, this is the part of our storage, and here, for example, we have our user manuals, which we are supplying also with our devices. And here is the rest of our storage. So here we keep all of the boxes, all of the parts of the cases, because our cases are consisting of many parts. They're not just one part, so we're assembling them from those parts, and here are they're kept. Here we have our server, and yeah, that's basically it. I think I will talk a little bit more about how we are assembling our devices again in our production.
Let's check that out.
But first, I will start that all of the testing is done here. So we have right now on their places 2 testers, and they're separately making all of the tests and double checking on each other. And we're not doing only the measurement. So, for example, here you can see some of the graphs which are taken before, and we're checking many of the parameters, so we are sure that our devices, when they leave the factory, they're complying our standards for many things like THD, but also we are making some simple tests like listening, because not everything can be seen on measurements, and sometimes, there are some strange behaviors for just one specific part, and then we have to debug it, what's the real problem, and many of those cases the measurements itself are not enough.
I agree with that. I mean, a listening test is the final test.
You have to basically combine both of the techniques, because one will miss one thing, some things, and the other one will miss the other things.
Okay.
And one thing, actually, here is a place when we are testing. This device is used for the installation of testing installation of our transformers. So, for example, Hypsos need to comply with specific regulations of the installation resistance and its resistance to many kilovolts voltages or of surges of voltage, but also we're measuring the resistance of the ground earth connection, because it can't have too much resistance, so it need to comply with this real low resistance level, and we're measuring it with this device.
Very interesting unit. Okay,
so here we are assembling our cases. So as I said before, here for example is a part which is only a back and the middle part of our case, and then it goes together with the bottom. We put it here. Actually, I think it's the other way around, because it's like that. And then we screw it together, as right now Andrzej is doing, and we're making, all the components are made here together. We're assembling them in our headquarters.
Truly interesting, everything. This part especially.
And also, many of our cables are assembled here as well. And the important thing that we actually had developed some simple devices to measure their performance if they're operated correctly in really simple way. So some of those LEDs will blink if the connection is right or wrong. And this really, smooths out the process of testing the assembly of the cable.
So every single part is being checked and double checked.
Yes.
Before shipping to the customers.
Yes, and some even when we are making some prototypes or when we have some defects on our boards, when we need to resolder some parts or exchange them, we're making this also here. Because we are ordering the PCBs, then they are also assembled in Poland as a first in a first way in a big company, but sometimes there are some defects and we need to fix it.
Yeah. Makes a lot of sense. What about these boxes?
So here we have also, it's also part of the storage. So we have some of the parts of, for example, for cases. They go in the edges of our boxes to keep them together. We have our already assembled vapor connectors for the boards. So we just, they are just put inside the case, and then they can be screwed to the motherboard. Or for example, some parts for our RCA connectors. Here, you have the rings to be able to tell which one is right or left channel.
So lots of raw materials.
Yes, it is a raw material for further assembly. And again, boxes which are ready to send to the customers.
Let's check maybe that part. Of the
there.
office? Yeah.
Yeah, there's also the boxes which will be sent to our customers, but also here we have some of the testing devices like auto transformers, because we need to test, for example, Hypsos on different mains voltages. We need to have a way to test it on Japanese 100 voltage mains or American 115 or 120 voltage mains. So yes.
These again are ready to be shipped.
Again, device ready to be shipped. And we go to our R&D section of our office. So here we are designing our software and our hardware. PCBs. We are designing it all here. Actually, as you can see right now, there is no one here because we have still a holiday season. So right now they're all on their vacation, and I'm only left right now. So I will talk you through this. What we are doing here. So yes, as you can see, we have many devices here. Guys here, for example, they have stacks of our devices on which they are testing all of the things and flashing the new software and checking how it operates on our devices. And here we have some even more testing devices. Here, for example, is an electronic load. So it was really handy when we were testing our Hypsos power supply, because it can arbitrarily make specific load for Hypsos or even changing load, and we were able to check the temperature rising or how fast the Hypsos is responding for the transients. Yes, and how stable it is. So this was really helpful in the development. Yes, and here's, for example, our evaluation board for Serce module, because this is our Serce module, and here's evaluation board in which you can, test some of the functionalities, and this is for our for companies with which we collaborate, so they can, test the new software and see how what they can do with the device.
Sure.
Because of course, after this procedure, they can put it inside their device just as it is done with Wandla.
Mm-hmm.
Okay, and here sits our CEO.
I know this guy. Hi, Martin.
Hi. So that's my place, my headphones, my amp.
And your midget.
What's on top of the amp? Hard to tell.
I think that Magda, what's that person on my amp?
He's warming
This
up.
figurine.
He's warming up. That's all.
It's Santa Claus.
We are waiting for Christmas already.
We're always
I
waiting
can
for
see that.
Christmas.
Maybe the Santa will bring me new headphones.
We are really
I'm thinking because I'm using these headphones. I like very much. I use them for a long time. However, I'm thinking about the change because it's kind of.
You just get bored.
I'm just got bored. So it's like how Max. When did I get them?
I think it's already at least 2 or 3 years.
3 years probably. I think so. So I'm thinking about other headphones, so that will be. I'm not much into changing things, but basically it's kind of, maybe that would be nice to change them.
Yes, and also there we have this stand with many books and magazines. But some of those books are become, example for me, really handy when I design the products, because, well, you always have to learn and you have to broaden the spectrum of your knowledge. So this becomes really important. Some of those books are really, really.
And last but not least, we have all 4
all of
products
our
that you are making
products
right now.
Yes, so I think I will start with the Hypsos. Actually,
This is the first product, huh?
Yes, it is the first product, but this one which I'm holding
Is the
is
second
actually our
generation.
newest product. Because we've made a small redesign, and we've added, when I was talking about the power splitter, this box which is splitting the power cables. So you were able to connect one of the cable here, and there's only one connector here, and then split it to 2 devices. Right now, you have the splitter embedded in the power supply itself, so you don't have to have 3 cables. You just need 2 of them, and it's much easier to and much better looking, because you don't have this much of the cable spaghetti. So it's much easier to use, but actually it works a little bit differently to the standard splitter, because I was talking before about the our cables that they have the 4 our cables have 4 wires. Two of them are for the power delivery, and 2 of them are for voltage measurement. And this is where the difference between Hypsos dual output and standard Hypsos comes, because when the standard Hypsos is using the splitter box, then the 4TSD, which compensates for voltage drops on the cable, is only able to adapt till the splitter itself, not after it.
Okay.
Here we have, actually I can show you this, because it's There is here main output, and auxiliary output. And main output has fully operational 4TSD function when auxiliary doesn't have it at all. So right now you are able to prioritize one of the outputs and decide, okay, so at this one I need the 4TSD connection. And for example, when you have some DAC and headphone amplifier, 4TSD connection is much more needed for the headphone amplifier because it makes much more transient currents which need to be compensated, and that's when the 4TSD function really performs really well. When DAC, it has quite often
it consumes the same
yes,
power all the
it's
time.
a stable current
stable.
and power consumption.
Yes.
So it doesn't need as much the 4TSD function. So right now you don't have to, give almost the same for both of them. You can give better one for the one which really needs it, and opt out of it for the one which actually don't really need it. But I focused on the differences between all the single-ended. I focus on the Hypsos with single output, not on the. I focus on the differences between single output Hypsos and dual output Hypsos. I finally made it. I should talk a bit more about actually what Hypsos is. Hypsos is our hybrid power supply. So we're using switching converters and linear regulators to make best of the both worlds, and it has many of the pre-configured devices which can be used with Hypsos as well. So you can just take it from the list and that's it. And about history, I think I will talk right now about OR, which is our headphone amplifier. Actually, funny fact is that it was my first big design, and I've started with 3 prototypes, and we've took one of them after extensive testing, and this was made as a final product. But in the meantime, we decided that we want to go with the power supply first. So then I switched to the Hypsos, and then got back to the OR, and this is how it was brought to life. So OR is our discrete headphone amplifier. We decided to go discrete because it's not because we don't like using at all the integrated circuits. We think they have their place and their usage, but for being able to adjust every parameter of the amplifier, you have to go discrete, because this is the only way when you can.
It's much more custom.
Yeah, yes, it's much more custom, because when you're buying some integrated circuit chip, you just have to go with it. I mean, there are some tweaks which can be done, but there's a whole another level of possibilities with discrete amplifier. But as well, it is some kind of the high risk, high reward design, because it can go really well, but as well there are so many things which can go wrong, and you have to be really careful to not blow it. After that, we decided to go with our first DAC as a Ferrum brand, but it is actually a headphone amplifier and DAC combo. So it is Headphone, because I think I didn't mention the name. It has the ESS 9028 Pro DAC chip, and it uses. Actually, here we have the integrated circuit headphone amplifier, but it's much more complicated than the typical one, because it is just not the one integrated circuit chip, but it is what is called the composite amplifier. So we have 2 integrated circuit chips which are working together to bring down the distortion and perform as well as this possible. However, it is not as powerful as the OR headphone amplifier, so this is not a flagship headphone amplifier. OR is our flagship headphone amplifier. And last but not least, here is Wandla. So it is right now our DAC only device, and it actually uses the ESS 9038 Pro DAC chip. And about the design procedure, we actually made the 7 prototypes of the current to voltage converter stage. This stage is converting.
How many?
7 prototypes.
Wow. Okay.
And we've made some kind of a tournament to decide which one we actually want to have as a final product. And we've made measurements, and after that we've made blind listening tests.
Interesting.
I mean, actually, I wasn't blind because I was choosing to which everybody is listening. So I said, you don't listen to me. What do you think? Actually, it was quite surprising because not the best in terms of performance on paper was chosen for the final design, because some of the parameters were better, some were worse. And after the listening test, we were actually able to choose which one of them we really want and we consider as our sound signature. This current to voltage converter stage is most important and differentiating factor from our ESS 9038 Pro DAC implementations, because it's done completely differently to typical solutions, and this was actually the bottleneck of those type of designs. We were designing on ESS 9038 Pro before, and after many years of experience, we decided that this is the one thing which we really want to change. Additionally, our sensor module, which I was talking about, I will just take one device and show you again. So yes, this is the sensor module, and this is our DSP heart, and actually that's why it is called serce, because serce in Polish means heart, and it is doing almost all of the digital functions, and it's actually combining some of the functionalities which were usually done with 5 separate chips. Here we are doing most of the things in our ARM processor. DSP functions oversampling. So yes, that's the most important part, and which is a distinct one, because we're making our oversampling with the HQ filters from HQ Player prepared for us by UC Laco from Signalist, and we're bypassing the first oversampling stage of the ESS. So we're able to have the full control over the first oversampling, and we're using our much better filters, which you can actually choose on the device on the fly, and you can actually even compare it with the typical ESS filters. And I think I have to mention, because after some time we decided to go with the Golden Sound Edition version of the Wandla, which we are cooperating on this project with Cameron Oatley, aka Golden Sound. We, in cooperation with him, designed 3 additional DSP functions. The first one of them is Impact Plus, which is basically a bass boost with a bass shelf and additional punch around 50 to 60 Hertz, just where the most enjoyable bass section lays. The second one is the tube mode. So actually, tube mode is quite funny, because there we're using the ESS DAC chip functionality, which is THD compensation, but we're doing it wrong. So actually, we're actually elevating the distortion, but only the second harmonic. So it's a little bit more close like tubes, but it's definitely not the same. It just makes a little bit more, gives a little bit more sweetness to the sound, and it's more relaxed.
Yeah, interesting.
In my opinion, the most important Golden Sound Edition feature is the spatial enhancement. So it's not a crossfit, it's completely different. It actually tries to widen the sound stage and make it more easy for you to pinpoint from where all of these sounds are coming. Actually, just making one more addition, here you have our current to voltage converter stage. So it's again a composite amplifier. So here is the current feedback, really fast low noise amplifier, which takes the current from the outputs of the ESS stage, and here are the current buffers. So they are making the output stage much more efficient in terms of delivering the current, and it's not overheating. And that's also because the ESS DAC chip has quite low output impedance as for the current output, and this needs high amount of currents to be driven properly. Most of the integrated circuit, just one operation amplifiers will start to distort, and that's why we had done it with a composite amplifier, because we wanted really fast, low noise current feedback amplifier, and to make it able to drive this impedance, we needed to add the current buffer.
Thank you, Max. That's a really invaluable information.
You're welcome. Yeah, and that's our headquarters.
That's pretty much it. Thank you, Max, for everything. Thank you
you
guys
very
for
much.
watching, and we'll continue with our video tomorrow. Yeah?
See you tomorrow.
Okay.